All right, so today we're doing central tendency, which that freaks me out because I didn't know what that word meant, but all it is how do I find mean, median, and mode, and then use box and whisker plots. So you guys have heard that before. You've done it in Algebra 1. We do it in geometry. So this is a 2-day lesson.
So who uses this? Well, statisticians can use measures of central tendency and variation to analyze World Series results. And if you really like this section, you should consider taking AP Stats with Mr. Stouffer because he teaches it.
Cool.
Recall that the measures of central tendency values represent the center of a data set. So here are three terms: mean, median, and mode. So mean, Miss Boyd.
Yes, the way I remember it. Mean is like the average of like your test scores. You take your test scores, you add them all up, divide by how many test scores there were.
Right.
So that's what we say. Sum of the values in a set. So we add them all up and divide by how many values there were. Average.
And the notation is actually X with a bar over it. That means average or mean.
Great.
Median, Miss Boyd.
That's like the middle of the set. So you have to put it in order from smallest to largest and then pick the middle. And how I remember, median has an I, middle has an I.
I like that.
So that's how I remember that one.
And what if there's two middles?
If there's two middles, then we add it and divide by 2. So we take the mean of the middle.
Got it.
Add them, divide by 2.
And last but not least.
And then mode, again, that O reminds me it's most often. So which number or value occurs the most?
I like that. A data set may have one mode, no mode, or several modes.
Okay.
That is possible. However, if you have a data set and every number only occurs once, that is a no mode.
No mode, yep.
Here we go. Well, maybe not. I can't seem to find. It like disappeared. Down. Okay. Should I hit?
Yeah, our technical difficulties. Here we go.
Example number 1.
All right.
Find the mean, median, and mode of the data. We have deer at a feeder each hour. There are 3, then 0, then 2, then 0, then 1, then 2, then 4. That's our data.
First thing I like to do is put it in order right away.
Okay, let's do it.
So I'm going to just put it in order from smallest to largest.
Okay.
So I got a 0. That takes care of that one. Another 0. 1. A 2. Another 2. A 3. And a 4.
Nice.
Okay. Great. Now we can go.
Okay, let's find the mean.
So the mean, we just add them all up and divide by how many there are.
Right.
So 0 plus 0 plus 1 plus 2. Oh boy, I did a count. Plus 2 plus 3 plus 4.
All over.
Let's count. There's 1, 2, 3, 4, 5, 6, 7.
7 of them.
Great.
And if we add all those together, we get 12 over 7, which equals, if we did a decimal, 1.7 deer.
All right.
Okay, that's our mean. Median, so let's write those in our, down there, so we can do the cross, the cross out. Okay.
All right, so we got a 0, a 0, 1, 2, 2, 3, 4. So mean, remember, is the middle. So we crossed off 1 from the front and the back.
Yep.
Cross off 1 from the front and the back.
Median is middle.
Sorry, yeah, median.
Median is middle.
Boy.
Yeah.
Cross off 1 from the front and back. We are lucky because it's an odd number, so we have a middle.
Whenever it's an odd number of data values, you always end up with one middle.
Yes.
If it's even, you're going to get 2 middles.
So then you add and divide by 2.
Take the average, yeah.
Great.
Mode.
Mode, which one occurs most often? Well, looking at our data set, we have 2 zeros and 2 2s. So our answer would be 0 and 2.
That's the mode.
Great.
Example 2. A weighted average is a mean calculated by using frequencies of data values. Suppose that 30 movies are rated as follows.
Okay.
There are 8 movies that are given a rating of 4 stars, 12 given a rating of 3, 7 giving a rating of 2 stars, 2 movies given a rating of 1 star, and 1 movie that people really did not like at all gave no stars. How you find a weighted, the key word here is weighted. We're not just adding 8 plus 12 plus 7 plus 2 plus 1. That's not weighted.
Nope, they're getting different
We're
points.
weighting them based on their rating. So we have to take 8 times 4, because that was given 4 stars.
Gotcha.
Plus 12 times 3 plus 7 times 2 plus 2 times 1 and plus 1 times 0, all over 8 plus 12 plus 7 plus 2 plus 1.
So the total number of movies, or you could have just saw 30.
Exactly.
30 on there.
You're right.
Okay.
So on top, when you do the math of all that, you get 84.
All right.
In
You
the
should
bottom,
get 30.
better have 30. And if you divide, it's 2.8.
So the average rating stars
Yep,
was 2.8.
2.8 stars. You got it.
Weighted average.
Right. And we're going to talk in class also, because think about your grade in this class. Your grade in this class is a weighted average.
Right.
60% is
Tests.
weighted for tests, 30%
for quizzes.
and 10% for homework. So obviously the tests are weighted way more heavy
Right.
than the other
Right.
categories.
Great.
Example 3. But before I do that,
Okay.
let's read what I have here. For numerical data, the weighted average of all of those outcomes is called the expected value for that experiment. Okay. The probability distribution for an experiment is the function that pairs each outcome with its probability. Okay? So all of these are kind of different kinds of weighted averages
Gotcha.
or means.
Mhm.
So example 3, the probability distribution of successful free throws for a practice set is given below. Find the expected number. There's the key word. We said expected number is going to be, when we wrote up here, expected value is a weighted average.
Okay.
Find the expected number of successes for one set.
So this
So-
is our sets.
Right, so what
Got it.
we're going to do here is take 0, or times 0, plus 320 times 1, plus 1/5 times 2, plus 1/2 times 3. Very similar to the other one, except we weren't given a probability, so we're not dividing anything on this one.
I see. That makes sense.
So see how it's different?
Yep.
On the last one, we weren't given a probability, we were
Right.
just given numbers, so we had to
So
have a
we-
denominator.
Right. So we already have a problem.
Here, we already
Okay.
have a probability, so you're just weighting that probability
Got it.
based on the number of free throws. When you do the math, so let's maybe down there write that 0, plus 3 over 20, plus 2 over 5, plus 3 over 2. And we need a common denominator. The common denominator is going to be 20.
20.
So we're going to have 0 plus 3 over 20. To change that, you have to multiply the top and bottom by 4. So that will give us 8 over 20. And on the last one, by 10 on top and bottom. And that's 30 over 20. When we add those all together, we will get 41 over 20, which is equal to 2.05. So the expected number of successful free throws is 2.05.
Got it.
And to the next page, we are going to save example 4 for
Yes.
class, because we would like to talk to you about box and whisker plots.
Mhm.
The box and whisker plot shows the spread of a data set. It displays 5 key points: the minimum, the maximum, the median, and the first and third quartiles.
We're going to talk about those.
We're going to talk about those. So the quartiles are the medians. Medians, that's the
So
key word.
middle.
Middle of the lower and upper half of the data set.
Yes.
If there are an odd number of data values, this is important. If there are an odd number of data values, do not include the median in either half. And you'll understand that as we go through an example
Okay.
and in class. The interquartile range then, all that is quartile 3 minus quartile 1. It represents the middle 50% of the data.
Got it.
All right, are we ready?
We're ready.
Here we go. We're going to do example 5 and save example 6 for class.
Again, I like to put them in order first.
Okay, let's
So
do it.
4, 5, 6, 6, let's see, 7,
Mhm.
8, 8, and a 9 and a 10. Got it.
So here I can actually represent something right away. My statement on the prior page said, If there are an odd number of data values,
1, 2, 3, 4, 5, 6, 7, 8, 9. There is.
do not include the median in either half.
Okay, so we're not going to include
Nope.
7.
So we're going to do a circle around the lower half of the data
Great.
and around the upper half.
So here's our quartile 1.
And there's our
and
quartile
our
2.
Quartile.
7 is not included in either set when you have an odd number of data values. Okay, are we ready to write our box and whisker
Yes.
plot? Okay. So we draw, yep.
Box,
Mm-hmm.
median,
Mm-hmm.
and our whiskers.
Yep. So I like to start with the minimum and max because those are really
Yeah.
easy.
The lowest number is 4.
Right.
Bam, goes here.
Yep.
Highest number is 10. Bam, goes here.
Right. 10? Oh yeah, yeah.
Yeah.
But yeah. Do we have to do dots? Do we have to do dots or at all, or
Oh.
like they did there?
I've seen it both ways.
Okay, so what do you want? I don't care.
Whatever.
Yeah, as long as this is good,
And then we bring down the 7.
which is the
For the
median. Perfect.
Great.
So we have covered now. Remember, in a box and whisker plot, we need a minimum, a maximum, and a median.
Here's our minimum. Here's our
So-
maximum. Here's our median.
For the fun of it, I think we should label just because we're
Sure.
learning. So let's write minimum, min. Let's write max, and let's write median. Perfect. Those are 3. Now we need a Q1 and a
Yep.
Q3. Quartile 1. Remember what quartile 1 represents? The median of the lower half.
Right.
Well, there's an even number.
Yes,
So there's
we
going to
have
be
a 5
2
and a
middles
6. So we add 5 plus 6
divided by
all
2.
over 2. So 11 divided by 2 is 5.5.
That is
That's gonna
Q.
go right here.
Yep, and that is Q1.
Ooh, that's hard to fill in.
It
Okay.
is
5.5,
and we'll label that
that's
Q1. Q3, look at again, there's an even number, so you're going to have 2 middles.
And 9.
Mm-hmm.
So 8 plus 9 divided by 2. 17 divided by 2 is what, 8.5?
Yep,
Great. So then this is 8.5.
which
and
is
that's
quartile
Q3.
3. We have found all 5, minimum,
Yes.
maximum, Q1, Q3, and median. The last thing we need to find is the IQR, which is the interquartile range. And
Oh boy.
interquartile, there you go, range.
And all we do is subtract Q3 from Q1, right?
Q3 minus Q1, or Q1 from Q3. Yeah.
So
8.5,
minus 5.5
and that's
is
3. You're done. Pretty straightforward.
Yeah, that's pretty easy.
We'll do example 6 in class.
Okay,
Okay,
great.
Number
We can
1,
do these.
number 2.
Easy enough. See you tomorrow.